we are learning the architecture of the digital signal processor TMS320C54x at present. In the previous session, we discussed the two blocks called the bus structure and the internal memory organization within the C54x digital signal processor architecture. The next block, what we are going to discuss now is the central processing unit CPU. The CPU of C54x digital signal processor contains an arithmetic logic unit of size 40 bit, two accumulators of size 40 bit, one barrel shifter, and a multiplier and adder unit which can perform multiplication of one 17-bit data with another 17-bit data, and the adder is of the size 40 bit. It has a unit called compare, select and storage unit, shortly termed as CSSU, and it has the data address generation unit and program address generation unit. About this data address generation unit and program address generation unit, I shortly briefed in the discussion of bus structure. This data address generation units generates the address in data memory where from the data has to be read or write with the help of the data bus. The program address generation unit generates the program memory address where from the data has to be retrieved from the program memory using program bus. Now we shall discuss about the arithmetic logic unit of C54x architecture. This ALU allows the digital signal processor C54x to perform 2's complement arithmetic operation with 40-bit ALU and 40-bit accumulators A and B. The digital signal processor C54x performs the arithmetic operations in terms of 2's complement mode with the help of the ALU, 40-bit ALU, and the accumulators A and B which are also 40-bit of size. It can also perform Boolean operations because arithmetic logic unit performs arithmetic and logic operations. It can do the Boolean operations called the logic operations, and it can do the arithmetic operations in terms of 2's complement mode. And this ALU takes the input as a 16-bit immediate value, or it can take 16-bit data word from data memory. It can get 16-bit value from the temporary register called T, or it can get two 16-bit data from data memory. It can get a 32-bit data from data memory, a 40-bit word from the accumulator A or B. So these are all some different types of data you can provide as input for the ALU. ALU can get 16-bit immediate value as the input, 16-bit data from the data memory, 16-bit data from the temporary registers, or it can take two memory operands as 16-bit data from data memory, or it can get a 32-bit operand from data memory, or it can get 40-bit operands from the accumulator A or B. And one more capability of this C54x digital signal process ALU is it can also work as two 16-bit ALUs, and it can do two 16-bit operations in parallel. The ALU size is 40-bit. It can act as a single 40-bit ALU, as well as if it is necessary, it can do parallel operations simultaneously as two 16-bit ALUs handling two 16-bit operations with the processor. The next is accumulator inside the ALU of the digital signal processor C54x. Accumulators, we have two accumulators of size 40-bit which are named as A or B. This accumulators A or B can store output from the ALU or multiplier and adder unit, or it can provide the second input to the ALU or the multiplier comes adder unit. This 40-bit ALU contains three blocks. the lower 16 bits are lower order word or the lower order data, and the next 16 bits are the higher order word. The higher 8 bits are God bits. This God bits is the new terminology available with the accumulator A or B, which is not available with the accumulator of microprocessor or microcontroller. These God bits are nothing but like margin bits. It specify the data availability locations, which is useful with the operations like correlation operation, which can be done with the digital signal processor. I don't get into the operations of the God bits and all because our syllabus is restricted only with the architecture. We don't go for programming. So this God bits are like margin bits, which provides the limitations to perform operation with the data available with accumulator. And the instructions can store any of these three portions in memory. If you, while doing operations with the ALU, the result will be stored in accumulator. The result stored in accumulator will have a lower 16-bit word and a higher 16-bit word and 8-bit God bits. If you want to store the lower order data or higher order data or God bit or any of the three, you can store it in memory. And this accumulator can also be used as temporary storage. For example, if any of your instruction needs to store the data in output device, external peripheral, temporarily the result is stored in accumulator, then it is moved to the external device. In this way, it is acting as a temporary storage also. The next unit available inside the central processing unit of digital signal process C54x is barrel shifter. This barrel shifter has a 40-bit input and a 40-bit output. This 40-bit input is connected either to the accumulator A or B or the data bus CB or DB. And the 40-bit output of the barrel shifter is connected to the ALU or to the data bus EB. This barrel shifter can do shifting operation of either left shift or right shift. And the shift count, how many times the shift operation has to be performed with the help of barrel shifter, is provided by the status register called ST1 or the temporary register T. When the temporary register provides the shift count, this temporary register is considered as shift count register. And this barrel shifter allows the digital signal process C54x to perform operations like numerical scaling, that is scaling the data to a minimum number of sizes, and the bit extraction. If you want to extract a particular bit from the multi-bit data, you can do that. This barrel shifter is useful to perform extended arithmetic operation in digital signal process C54x. What is extended arithmetic operation? I can explain you with a simple example. We can do the multiplication or division by the powers of 2 with the help of shifting the data left or right. Multiplication by 2 is nothing but shifting the data by 1 bit left. Division by 2 is nothing but shifting the data 1 bit right. In the same way, multiplication by 4 is equivalent to shifting the data by 2 bits left. Division by 4 is equivalent to the shifting of the data by 2 bits right. And it is also used to perform overflow prevention operation. You can avoid overflow of the data by doing the shift operation with the help of barrel shifter. The next block available in the central processing unit of the digital signal process C54x is multiplier adder unit, which is shortly represented in my notes as M&A in the previous slides. This multiplier adder unit can do multiplication in the form of 2's complement mode with two datas of size 17-bit. It can perform multiplication of one 17-bit data with another 17-bit data, as well as it can do a 40-bit addition with that particular multiplication in single cycle. This multiplier and adder unit available in C54x digital signal processor can perform one multiplication of 17-bit data with another 17-bit data in 2's complement mode and a 40-bit addition both in a single cycle. That is the processing speed of this multiplier and adder unit. This multiplier adder unit contains a multiplier to do multiplication, an adder to do the addition, signed or unsigned input control logic which gets the input and provides the input to the multiplier and adder, fractional control logic which deals with the fractional part of the data when the data to be operated by this multiplier order unit is a fractional numbers, and a zero detector, it's like a zero flag to indicate whether the result is zero or not, a rounder which converts the fractional result into integer part which is used for the conversion of this fractional part to integer part, and overflow or saturation logic which is very similar to a overflow flag or a carry flag to indicate the overflow, a 16-bit temporary status register called T. These are all the different units available in the multiplier adder unit. And this multiplier adder unit takes two inputs. One input is from the temporary register T or as the operand from the data memory or from the accumulator. Another input is taken from the program memory or from data memory or from accumulator or as an immediate data. This multiplier adder unit allows the digital signal processor C54x to perform operations like convolution, correlation, filtering, etc. This multiplier adder unit in one cycle helps to calculate Euclidean distance in LMS filters. This is one application I highlight. In LMS filtering operation, which is a topic under digital signal processing, we need to calculate Euclidean distance. With the help of this multiplier adder unit of C54x digital signal processor, you can calculate the Euclidean distance within a single cycle with the help of this multiplier adder unit. Next block is compare, select and store unit. This CSSU, compare, select and store unit, is used to perform the comparison between the accumulator higher order word and the lower order word. The two 16-bit data as higher order word and the lower order word of the accumulator can be compared. And this comparison results affects the test or control bit called TC in status register ST0 and the transition register TRN. The transition register will be enabled and the test control bit will be set or reset based upon the comparison result whether it is greater or lesser. And this compare, select and storage unit is used to perform Viterbi type butterfly computations with optimized on-chip hardware. With the on-chip hardware available with the C54x digital signal processor, this compare, select and store unit available in the CPU of the processor allows to perform butterfly computation of Viterbi type. This is about the central processing unit of the architecture C54x. We shall discuss about the remaining blocks in future sessions.